Here, we're trying to determine whether two lines are inverse functions of each other. And if you have the equation, it's pretty straightforward to do that. You can just find the inverse of the equation. Let's look at this line right here, for example. We don't have the equation of it. I'm not going to take my time to try to figure out what the equation is from the graph. Let's just say, I'll guess here, let's just say it's y equals 3x, it looks like plus 3. That may be what the equation is, I don't know. If we wanted to find the inverse of this, we would switch x and y. So instead of y equals, I'd say x equals, and instead of 3x, I'd say 3y plus 3. And then I would go ahead and solve that for y again. So let's see, I'd subtract 3 from both sides, and we'd get 3y, I'm just going to write the y over here now, equals x minus 3. Then I'd have to divide by 3. Divide everything on this side by 3. So we're going to get y equals x over 3, I'll write as 1/3 x. So we have the slope right there. And negative 3 divided by 3 is negative 1. So here's our inverse of this guy. And there are a couple of things you should notice about this. First of all, the y-intercepts. This one's positive, this one's negative. If one y-intercept is positive, the other one's going to be negative in inverse lines like this. So that is something to look for. And then the slopes are going to be reciprocals of each other. So if this slope is 3x, this slope is going to be 1/3. So those are the keys in looking at inverse lines. So if we're being asked, is this the inverse of that first line? Well, let's see. It does seem to cross the y-axis at about -1, and it does have a shallow slope that could be a positive 1/3. So chances are these probably are inverse functions, or at least very close. There are a couple of ways to test it. And let's look at this problem and another. Here, they're asking us to determine whether these two are graphs of inverse functions or not. So the shortcuts here, first of all, is check the y-intercepts. If one is positive and the other negative, that's a good sign. But it's not all you need. The second thing is that you should bisect the angle formed by the intersection of the two functions, the two lines. If it's a 45-degree angle, and that would be relative to the x-axis, and that first condition is met, then you're good to go. So the way I would do this if I just had graphs, first of all, I would check to see, is there one intercept that's positive and one that's negative? If I look at the second one, they're both positive. I can just reject that right off the bat. I don't need to worry about it. In this one here, I've got one that's positive, one that's negative. So this could be uh, an example of inverse functions. And then what I would do is just draw a 45-degree angle. So the easiest way to do that is just start on one corner of the graph and draw a line up straight up to the other corner of the graph. Now this line doesn't bisect that angle yet, but I can make it do that just by moving it around. There we go. So I'm going to try to move this line. Well, I guess I'm going to try to move the graph until it's right in the middle. So now that line is bisecting the angle, and it does look like it effectively bisects the angle. We don't have it looking much bigger on one side or the other, and that's a nice 45-degree angle. So I would say yes, this first one does represent the graphs of inverse functions. So check the y-intercepts. They need to be one positive, one negative, and then see if the bisector of that angle runs at a 45-degree angle. If that's the case, you've probably got inverse functions.